Let us talk about this problem. We are given a doubly linked list and a data item. We need to insert this data item at the end of doubly linked list. So we have this doubly linked list and we have data item as 40. We want to insert this 40 at the end, right? So this is the required output from this function. Now if you see this example, our linked list is empty and data item is given as 40. So we want to insert a new data item and we want to make it head because there is nothing in the doubly linked list already. So this is the only case where we change the head reference or pointer when we are given an empty linked list. In all other cases, head remains as it is because we are always inserting at the end. Now please pause this video and try to write down this function that takes head as a parameter, data as a parameter, inserts a new node with the given data at the end and returns the modified head of the linked list. Please note that head is only modified when your given head is null, otherwise it is not modified, it remains as it is. Let us consider this example to understand the algorithm. What are we going to do? We are going to begin from the head, then we are going to traverse till the end. So we are going to find out reference or pointer to this node. Right? We begin current equal to head and we run a loop while current arrow next or current dot next does not become null. Once you reach there, you can simply insert a node after it. And why did we reach here? Because to insert a node after a given node, we need to change next of it, right? So we need to have handle of this node. And we also need to set new nodes previous as this node. So this node is very much required. And to find this node, we run a loop from head and we put this condition while current arrow next or current dot next is not equal to null, keep running this loop. And you will stop when your current is here. So once you find the current, you just need to change few pointers. You need to make current dot next equal to new node or current arrow next equal to new node. And you need to make new node arrow previous or new node dot previous equal to the current. Now please pause this video and write down the complete function. Let us now see implementation of insert at the end. As we discussed earlier, we begin a current reference or pointer from the beginning. Current begins from the head and this loop takes current to the last node. This condition is really important. If you remove next, what will happen? When you come out of the loop, your current will be null. If you put current not equal to null condition instead of current dot next equal to null or current arrow next equal to null. Many students make this mistake when they begin with linked list programming. We want to get hold of the last node and we'll come out of the loop when we find a node whose next is null. So we'll come out of the loop when we reach the last node. So current will move from here to here, its next is not null, its next is not null, then it will come here and its next is null. So current will stop at this point. That's how we find the last node. After we find out the last node, our job is simple. We already have allocated node as a first line of this code. So we have allocated a node with reference or pointer as temp and this value is 50. Right? So what are we going to do now? We are going to say current.next equal to temp. This is linked with this and temp.previous equal to current. So we make this previous equal to current, right? So temp is added at the end of this linked list. Now there is one corner case we need to handle. If somebody gives you a linked list which is empty, in this case, there is no previous node, right? Null in C++ or null in Java. So in this case, what happens? You create a new node and you simply return this new node as a new head of this linked list. These functions are supposed to return head of this linked list. And insert at the end modifies the head only when you pass an empty linked list. So what will happen when you pass an empty linked list? You will create a new node. Say you want to again insert an item with 50 value, right? This is a different case we are talking about here when somebody is passing an empty linked list. So you will create a new node and then you will simply return this as a new head. So this will become your new head. Right? That's the idea of this implementation. Here is example usage of this function. This is main function Java and this is main C++. So we initially have head as null when we call insert begin, it goes into this base case, right? This basic corner case. And what it does, it creates a new node and returns this as a head. So a linked list with single node is created when you pass head, and this becomes your new head because we are assigning return value back to head here. This function returns this temp and we assign it back to head. Now we pass this head again and we insert 20 at the end. So what happens now? 20 is added at the end of this linked list. So 20 is added here, and this time the same head is returned back. You passed head which was referring or pointing to 10. The same head is returned and you still have the same head. So that's how this insert AND function can be used, and it always inserts at the end whether you pass an empty linked list or you pass a linked list with some nodes.